And it looks like we're live. Almost, well, I actually did forget to close the door, so that's why I started streaming, and then I was like, ooh, I should probably go close the door before I wake everybody else up here with my talking about Rust, which I don't know how much others are interested in that this early in the morning instead of sleeping. All right, so a couple seconds until 7, so we can wait a little bit to start. But today we're going to be starting work on our nth Fibonacci Rust, which is the second of the projects in the Rust book, which is super exciting. We're sort of slowly moving through Rust here. But I also feel that what I've been doing has been really productive when in learning, and that's mainly because as I'm seeing things, I'm attempting to use them before the book has covered them. So references and borrowing is coming up in the next chapter. And I know that, is there anything else? Strings. We just did a lot with strings, and Danny told me yesterday that he believes that the strings STRs are pronounced stirs. So I think I've had 2 people tell me 2 different pronunciations, so I'm not sure what exactly is the most appropriate for strings. So if you want to weigh in on that, please leave a comment. Let me know. How do you pronounce stir or STR? A lot of really awesome stuff coming up. Love that there's a chapter, Is Rust an Object-Oriented Programming Language? All right, I also want to turn on my preview here so that I can see chat. All right, it's looking good. Chat's loaded. Everything's looking good. 2 viewers, which may or may not be me. I don't think there's an actual way for me to see participants. Mostly one other person, but all right. So, welcome to the stream. We're finally gonna start on Fibonacci number this morning. So, let's see. I think last time I'd already actually created the project, so all I need to do is actually start working on it. Good morning, Felix, and good morning, Avarice. Welcome to the stream. Really interesting. I have the preview window, like the Creator Studio for YouTube on my left window, and then it has a chat there, and it starts from top down. And on my tablet, I have the chat, and it starts from bottom up. Doesn't mean anything. It's just something interesting to my tired brain. Gurpreet, welcome to the stream. All right, so we just have a hello world here. We don't have anything at all. And so the idea is that we're going to generate the nth Fibonacci number. So I imagine that it's going to be something like this. Fibonacci numbers they can never be negative, so there's no reason to have a signed integer. It should be an unsigned integer. So what would that be? We would want let my fib number equals, and then calculate Fibonacci to some degree, like let's say the fifth one. And if we do that, then we should be able to print line. The fifth, what is it? Sequence, version, number in the fib sequence is, and then we're going to do a fib. Okay, so I mean, yeah, we're done. All we have to do is calculate fib. Now I know that there's a whole bunch of ways to do this. There's like the classic interview way that everybody always asks in an interview, which is the recursive way, which is the way that you never, ever, ever want to do it in a real life situation. Because that has a terrible big O. But there's also just like normal ways of doing it. And it could use data structures like what we learned yesterday or the day before, structs, that those exist and can be used. We could also use tuples or arrays, because these are all going to be unsigned integers. Do I care about anything else? I don't think I do. Let's just go with like an easy one and just use variables for right now, and then we can play around with it and potentially do the recursive one right afterwards, just to sort of see how Rust handles that. All right, so we want function calculate fib. This is going to take in a sequence, like the index. I'll call it sequence number. Just sequence, maybe n, because that in math that means what? It's going to be an unsigned. Let's go 32 right now, and we're going to return and unsigned 32. Okay, so calculating fib. Well, the general idea from what I remember is that we also have to decide if we're starting from 0 or from 1, but it's the last two in the sequence added together. So if we have 0 and then 1, like we have to arbitrarily assign these first two, but then the next one is going to be 1 because it's 0, 1 added together. And then the next one will be 2 because it's these two added together, and on and on and on. And then the nth will be whichever one we want to point at. So we have to decide, do we start with 0 or do we start with 1 and 1, 1? And I don't actually remember if there's an official mathematical Fibonacci sequence. Series numbers in which some true, the simplest is the series. Okay, so the fact that it says the simplest in a series, oh, you know what? Because I think I remember reading that you can do the Fibonacci sequence with any series of numbers. You could even start at random, like a random number, just to sort of see what happens. Okay, in mathematics, the Fibonacci numbers starts with 0. Often, especially in modern usage, the sequence is extended by one more initial term, 0, 1. By definition, they can only, yeah. So it looks like we get to choose. Let's try 0 and 1, since that says it's what like the modern usage is. So that'd be 0, 1, 1, 2, 3, 5, and so on. Okay, so I know that we have to start with these. So these can be our constants, or we could just set them as variables. Like whenever we call this calculate fib, we're starting with 0 and 1. So let, I guess, let first equals 0. Let second equals 1. Oh, it had a green undersquiggly from... The code is good. Also, I realized that this, well, it might be helpful. I can read it a little bit on my screen, but let me know if this text should be any bigger. Okay. I'm actually going to go ahead and just make this full screen. Maybe we can put this over on the right. Okay, so we're calculating fib for second. And then we're just going to loop through until we hit this. And when we do, that's when we know that we want to go there. Now, I remember there's a couple different loops in Rust here. So I think it was in control flow. And there's looping through a collection. That's not really what we want. Conditional loops with while. So I don't think I've really experimented with it, but let's say I want to do this. Let's say I want to do while n is, well, okay, while n is greater than 0. So I might count down from this. And sort of like drop it down, and as soon as we reach 0, we know we've been adding these together, and so we don't have to then keep these all and then waste that memory space. So while n is greater than 0, what is the next? Oh, there's no colon or anything. It's just block, and then we do things like print line, bang, and then it will be, ooh, okay. I'm getting weird, like the green squigglies from, I guess, RLS as it's complaining, but then it goes away. It's tricking me, and it's making me think that something's wrong when it's not necessarily. Okay, so then I just want to have n. So if we save this, there's no errors here. Let's bring in our code over here, and we're going to do cargo run. Well, while RLS doesn't see an error over here, 2 positional arguments. Oh, yeah. Also, this doesn't really return something. So let's just return 55. Oh, and also the nth number. So let n equals 5. Okay, cargo run. Infinite loop of all just 5s. Okay, so, well, that kind of makes sense, right? Because we never did anything with this. Now, I could do something like minus minus, right? And that will, if it's like, ooh. So it won't let me do that. I will need to, if I let, this is probably not mutable, so this is, I'll have to have like a count, and I might be able to do a count minus minus here. And here I can do a let mute count equals n. Still doesn't like that. Okay, so it doesn't want me to do my decrement mount. Function calculate fib should have case name to your right. Okay, save that. Variable does not need to be mutable yet. What if I do now? Now you're saying expected expression found this. Okay, so it doesn't like me to use that in there. So instead, I can count equals count minus 1. First and second, yes, I know I'm not using those. I'll just comment you out so you don't yell at me. Let's try this again. And of course we want to count. There's no increment decrement. I am finding that out. That's fine. I got used to that in Lua, so I will just use this method. Okay, so this is our standard loop going down. We can actually count up now too, because we can just say let mute count equals start at 0. Well, count is less than n. Then count. I kind of like this. It makes it a little bit more familiar to me. All right, Felix and Everest, both of you reminded me that there's no increment decrement operators. Thank you both. Okay, so we have our count. It's going up and down. You can do count minus equals. Oh, so it does do that type of thing, but not the other. Okay. So I can do plus equals 1. That works just fine. Thank you. Okay, so now we can start playing with this. We want to take maybe have like a current. That current equals. See, I don't know if I care about that. Oh, these should all be mutable because I'm going to be reassigning them. Mute. And I don't really like the names first and second. I hope I can figure something else out for this. So we're going to take first and second. So first is going to be added by second. Oh, so we don't want to start at 0 because considering where we would determine, if we start with 0, then 0, 1, we should really start with 2. Because 0, 1, 2 will be these added together to become the next normal. So we will do, and at this point in time, I could probably not do, I need count just to figure out when to do it. So current, do I need a current? Because what I'm gonna say is, yeah, I have to add these together. So let mute current equals just nothing. And the only reason I want to do this out here is so that I don't lose the scope inside of here. if I give it a type down here, it should figure out the type up there, right? So if I say current equals first plus second, no, it still wants me to say that this is unsigned 32. Yep, then I guess I'm not using it. It's never been read. Okay, so yet. It's gonna be, we're gonna need to do that, compiler. It's okay. Okay, so we set the current equals to first plus second, and then we have to slide everything down. So first is going to become second. So first is going to equal second. And then second is going to equal current. And I think it's this Tower of Hanoi problem that causes me to have to do it in this way, because if I do this first, I lose the values when adding them together. Then we count +1 and we continue on. At the very end, we're going to return second. So if I do this, and I ask for cargo run, the fifth number in the fib sequence is 3. So if it really is 0, 1, 2, 3, well, that doesn't exist, but 1. So off by 1, because it got it right there. Okay, so let's think about this. The fifth sequence, so 0, 1, 2, 3, 4, 5. Or 1, 2, 3, 4, 5. Okay, never mind. I was thinking 3 for some reason, not 5. But we asked for 5. And we got this one right here. And is that correct? Is this how we want to define Fibonacci sequence? Starting with 0 or starting with 1? What does this say? Is it indexed by 0? I'm not really sure. Use some mathematics. I'm not sure where we would count from. Now, if I begin with, if I just want to begin with 0 and just say, hey, we're computer programmers, we always begin with 0, unless we're in, a language that doesn't. Then we just ignore that rule. Okay, so if we begin this with 0, so this is 0, 1, 2, 3, 4, 5, but that is 6 numbers. So then I wouldn't want to stop at less than. I would want it to be less than or equal to. Then when I run this, the fifth number in a fib sequence is 5. So I wonder if, does anybody have, okay, so starting with 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12th should be 144. So let's do that. $144. Okay, so it looks like we have a working Fibonacci sequence here. But it might not necessarily be exactly how I want this to be. Well, let's try commenting this out and doing the recursive one and see whether or not I haven't looked up, can Rust do recursion, and if it can, how good is it at it? All right, so we'll do function calculate fib. We're going to take how do I want to do this? The nth digit of it. So that will just be, I think that's just fine. NU32. I have to remember now how to, the full like setup for it. U32. Okay, so first exit case. If n is equal to 1 or n is equal to 0, I think that's enough. Then we want to return 1. Why are you yelling? If may be missing an else clause, expected parentheses found U32. What do you mean you expected parentheses? Rust can do recursion, but it doesn't do tail call optimization, meaning, okay, so I can't, well, Fibonacci isn't tail call recursion, so that won't be a problem, which is why the while loop is preferred. That's like the truth in almost every single language. So I'm not that surprised by it. But expected. So if maybe missing an else clause, which I don't think it is. Also, I told you, calculate fib, you're returning a U32. Why are you telling? Okay, I don't know. Return 1. That's fine. There, I'll make you happy with an else clause. Now it's going to say, expected U32 found, code, your IDE editors. If n was not 0 or 1, what should the function return? So in this case, because it's Fibonacci, it's going to call itself. So we're going to return calculate fib, and we're going to pass in n minus 1. So n minus 1. And then, but we need to add this together because it's the last two in a series. It's because you return called unit outside of the if. Did I? I thought I returned it right here, which would be in the body of the if, but maybe that is outside. Plus calculate fib and pass in n minus 2. Okay. So this should, I'm not going to do 12, I'm going to do 5 again. This should calculate out 5, I'm hoping. The fifth number in a fib sequence is 8. So, which would be the next one right here. Oh, you know what? Because this one is starting with 1, 1. That's the problem here, is that if I want to do the exact same way, I need to do, you know what? I wonder if a match would be better here. And then I could customize this a little bit more. Also, if it's a match, would this technically be 1? This would technically be, oh, you know what? I could just do return n. If it's 1 or 0, just return n. There you go. Do this again. Fifth number in fib sequence is 5. So now if I say 12, let's take a little bit more power. 144, so it is working now. And this gets significantly worse the bigger number I ask it to do, like 15. $6.10. Okay, so it's still pretty fast, and it's unoptimized too. What if I do 25? I can't remember on my work computer when I showed the students how to do this. Okay, this is still pretty fast. 50? I mean, eventually it's going to just lock up and take out my... Here we go. This is taking a long time. Yeah, so this will take far too long, but that's ooh, and I just, what time do I need to do that? I need to do a really quick check because I'm on a flight tomorrow. Do cargo run release. So one question I have is, what does cargo do? Okay, right after I stop the stream. I want to check into my flight tomorrow, and that's gonna be right after I stop my my stream. I'll be able to do that. Do cargo run release. Okay, let's try that. Control C. All right, so cargo run dash release. See if it's a little bit faster. Took a little bit longer to compile it, but that makes a little bit of sense. But no, it looks like it's still doing actual recursion. So I know that there's some languages out there that will refactor when you compile for release into like for loops or while loops from recursion, just to make it faster, and also so you don't run into stack overflows. But that is not the case here. It is still a terrible big O for us. So this is the other way to potentially do it. I kind of like the idea that if I was going to do this one, that I use a match here, because then it's technically one line. I can say, okay, match n, and if it's if this n is 0, I want to return 0. If it's 1, I want to return 1. And if it's any other number, I want to... Ooh, it finished. Okay. 50 number in a fib sequence is this. What profile? I wonder what profiling information. I wonder if the book is going to get into profiling stuff. Because that would be really nice to sort of like see, okay, well, how long did this exactly take to do? How many sort of iterations did it create? Because this is filling up the stack quite a bit. Also, I wonder how big the stack is for Rust. Like, well, how long can I go before it stack overflows? So I think this just holds the number, right? This is going to be type U32. So now I can just calculate fib. It's going to be -1 plus calculate fib underscore -2. So if I save that, expected expression found underscore. Do I have access to n in here still? I guess I can. I don't want to do 50 again for this. Let's do 25. Was that the same as this other one? Underscore specifies to ignore the value. You can use a name to bind the value to it. Ooh, interesting. So that's like a, yeah, so that was working there. How do I do that? Is that in the book? Is there like a more, the match control flow operator? See, oh, that's just in there. I'm wondering. Match the coin, but that's just accessing something inside of it. That's just matching some I. Oh, is some what that is? Let 5 equal some 5. Okay, so let's see what sum is. The sum value doesn't match the pattern, none, so we continue. The I binds to the value contained in sum, so I takes the value 5. Is that how this works? So I can do some num. Expected U32, found enum, standard option. Oh no, I think I'm guessing now, which is not the best. Oh, here, this placeholder. This is similar to what I want to do. Just replace the underscore by, hold on. Let's put it back to what it was previously. Okay. Just replace the underscore by m or some other variable, then use it in a match arm. Oh, really? So it's just like num like that? And num. Okay, that's pretty cool. Malcolm, good morning. Welcome to the stream. Then yeah, that's working. Okay, that's pretty cool. I thought for some reason that the underscore was a catch-all, but this is just it's just a variable that's literally catching everything. And okay, that makes sense. This feels a little bit nicer than this pattern up here. I mean, I guess technically it's now a one-liner, so that's nice too. Still gonna use, okay, so I think this is fine. Is there any other methods of calculating Fibonacci we want to care about today? I think there's like some, oh, there's, I'm vaguely remembering that there's a way, there's an algorithm for doing an infinite fast recursion without worrying about the stack. It keeps it nice and fast. I think I can okay, I can memoization. Yeah, I can do memoization. I can also do trampolining, then that makes it actually not really recursion anymore, because I'm creating new functions, so it's actually keeping the stack down at 1 every single time, like maybe up to 2 every once in a while, but it sort of resets the stack every single function run. So those are my 2 options. I don't know if I want, because that's not really going into Rust stuff. That's really just going into computer science things. And that might be different streams to look into, like, okay, let's play around with memoization and so I want to say this, but you can use calculate, fib, mute, and 32. Oh, so I can set this to be mutable right here. Okay, so now, oh, not this one. This function is fine. It's this one. So I can set this to be mutable. Let's take this out, bring this back. Mute n equals this. So now we don't need a count anymore. Which means we're going back into greater than or equal to 0. And we're going to go with n, and n minus equals to 1. Save that. Comparison is useless due to type limits. Oh, wait. Can unsigned not be 0? It has to be greater than 0, isn't it? Oh, does that mean I have to sign it? Does that mean it has to be an I? Oh, interesting. You don't need it in this case. Yeah, I don't need it, but it's interesting to sort of play around with. I got a very different number though. That's because I'm starting. Wait. So if unsigned 32 cannot be 0, it's just complaining they'll always be greater than or equal to 0. Oh, so it's saying that it's going to be an infinite loop? All right, hold on. Let's try this. Oh, let's turn off release. Will you give me overflow, stack overflow? So yeah, this is an infinite loop, isn't it? So, oh, unused comparisons on by default. So this comparison never happens at all. While n is greater than or equal to 0 and minus equals 1, it's starting at 25. It should like go down until it's -1, but it can't because it can never be -1. So I would need to be greater than 0 So if I do this, also I need to do it up there so you can see it. 25th number in a fib sequence is 121393. And if we start with something that we know is 8. Now this is going back to 1 1, like starting with 1 1. Because of the way it's set up, it can't I can increase n. So like the first thing that I can do is say n plus equals to 1 to sort of force it. Integer underflow. Oh, that's interesting. I don't think I've seen a language do that before. The fifth, minus equals 1. Now we get the number we want to get. So now we can go around and say 5, the 500th, this loop will be significantly faster than anything else. Still failed for this. So this is an panicked at attempt to add with overflow at line 19. So, wait, is it because I'm using unsigned 32? I could switch these to 64-bit and get bigger numbers. Yes, I think you just told me that. Felix. Thank you, Felix, for telling me about mutability and also the 64, like making sure 64-bit here. It's 64. All right. Let's do this again. Bigger numbers. Okay, so this is too big of a number even for 64-bit numbers. Is there another number that I can use? I don't remember. Data types. I can do usize. U128 is not yet stable. I can do usize though, right? Is that just like the unlimited size that's unsigned? So unsize, just whatever it can be. I vaguely remember. Additionally, the isize and usize types depend upon the kind of computer your program is running on. 64-bit, oh, never mind. It won't, it's literally no different than 64-bit. So I probably don't, I'm not gonna have access to anything bigger because I don't think I'm running a nightly or a beta version of the language. And it's not unstable yet. So I won't be able to go up to 500. It's interesting though that I can do this to say like, hey, whatever size I can use, just use the biggest. So what can I do? Can I do 300? Nope, that's still too large. 100? $100 still is too large. I know that 50 should work. Yeah, 50 gives me this. I just want to find the edge. $75 gives me this. It's getting close. Is there like a max int in Rust? Like I know that there's one in some other languages, so I wonder if I could calculate, like print that out. 80. $80 works. 90. 90 works. How close to 100 are we going to get? Below 95. $94. Here we go. The 93rd number in the Fibonacci sequence is the maximum number we can use in 64-bit unsigned integers. And it is a very, very large number. One, I don't even know, let's see. That's thousands, millions. Oh man, then once we get out here, I don't know, like it's Googillions, and then there's some other crazy number names. I don't remember those. Okay, so we're 10 minutes away from the end. I sort of like ended up playing with this a little bit too much. But we have a couple different ways to do this. I didn't really need any data structures at all, it turns out. It was just more math and working with functions and returning them, and also playing with match as a way to turn the recursive version of calculate Fibonacci into a one-liner, which I think is nice. So before I forget, I am going to save this. Oh, this is trying to send. Did I not create? I don't think I created a ls-al. I do have a get ignore. So cd.get ignore. Oh, not cd. vim.get ignore. Oh, I need to do /*. So by doing that, it should update here, maybe. Refresh. There we go. So now we're only seeing, okay, our cargo toml, our main RS, and our get ignore. So we're going to add these in. And we're going to say 3, you're connecting drop frame 0. It did freeze on the stream on my tablet a little bit, but it looks like I'm back. I don't know what happened. There was no drop frames. The live count didn't reset. CPU hasn't been that high. The internet didn't die. I guess I could look at the history thing. But that was... Oh, again. OBS is flaking out on me. All right, 3 different ways, either OBS or YouTube. 3 different ways to calculate the nth position in the fib sequence. Okay, I do not know what's going on with my internet or OBS, but until it I am losing my ability to stream apparently. So with that, I'm going to just call an early stream because I think that's for the best. Anyways, everybody, thank you for coming out and joining me on the live stream, waking up with me this morning. And tomorrow I will not be streaming. I will be traveling and I will be out. I'll be away from fast internet until Wednesday morning. So I'll be keeping this. I'll be mentioning on Twitter that I won't be streaming, and until then. But these videos will be online and live, and I won't continue working through the book, so I can continue that on Wednesday. All right, with that, I hope that you have a great rest of your day and a great weekend. I'll see you next week. Have a great one. And click.